Precalculus AP question about rockets and quadratics, parabola. A model rocket is launched straight up. The rocket was 160 feet high at 1 second after launch. At 2 seconds after launch, it was 287 feet high, and at 3 seconds after launch, it was 382 feet high. The question asks to draw the situation, so I'll graph it at the end, and then answer the questions, and if necessary, to the nearest thousandth. So first, find the quadratic function to represent the situation. So the question has given me 3 points, 160, so I'm just going to write these down. When x is 1, let me zoom. I'm trying to zoom in so I can see it. Okay, here it is. When x is 1, y is 160. When x is 2, y is 287. And when x is 3, y is 382. And I want this equation to be something like a t squared plus bt plus c, and that's going to equal h of t. So I need to find a, b, and c, 3 variables, 3 unknowns. I can use a TI-84 calculator or Desmos on the TI-84. I go to stat, enter, and I enter the x values in L1, the y values in L2, then go stat and calculate and quadratic and put L1 for x and L2 for y and calculate, and it'll give me the answers. Or I can do it like this by hand. I will plug in when x is 1, y is, or h of t is 160. So 160 equals t, well, I say x here, it should be t. I think on Desmos I would write x instead of t. But anyway, so when t is 1, 1 squared times a is a, 1 times b is b, plus c. That gives me hope that this will be easy to simplify. And then at 2 seconds, it's 287 feet high. So a times 2 squared is 4a. B times 2 is 2b. Or not to be, no, it's 2b. And then just plus c. And then at 3 seconds, it's at 382. So 382 equals 3 squared is 9, 9a. I'm just plugging in 3 for t, plus 3b, plus c. 3 equations, 3 unknowns. I will subtract the first equation from the second equation. That gives 127, 287 minus 160, equals 4a minus a is 3a, 2b minus b is 1b, and then c minus c is 0. And then I will subtract the second equation from the third. 382 minus 287 is 17, 18, 95. 9a minus 4a is 5a. And 3b minus 2b is b. And c minus c is 0. So now 2 equations, 2 unknowns. I will subtract the second from the first. 95, 105, 115, 125. This is 32 equals negative 2a. I'm just subtracting the second equation from the first one. B minus b is 0. So a equals 32 over negative 2 equals negative 16. So now I know a is negative 16. So this is negative 16 t squared. And this is equal h sub h of t. If I'm not writing this in the right place, I'll fix it later. And then I've got to find b. Well, 127 equals 3 times negative 16 plus b. I think I'm going to need more room. Let me see if I can expand this. Well, not much. Can't expand it much. Let me get back to this point. 3 times negative 16 is negative 48. I will add 48 to both sides. 127 plus 48 is 175 equals b. So now I know it is, this one actually goes over here. Negative 16 t squared plus 175t, and I've got to find what c equals. 160 equals a plus b plus c. 160 equals, a is negative 16, plus 175 plus c. And if I add 16 to both sides and subtract 175, I get c equals 1. So I have negative 16t squared plus 175t plus 1. That's h of t. How high was it when launched? Well, when launched, t is 0. So h of 0 equals negative 16 times 0 squared plus 175 times 0. That's just 0 plus 1 equals 1. So h0 equals 1. How high was the rocket 5 seconds after launch? H of 5. Just plug in 5 for t. I'm just going to do this on Desmos. You can do this on your TI-84. I'm going to get negative 16 times 5 squared. Well, wait a minute. I'm just going to put the equation. Negative 16t squared plus 175t plus 1. And I'm going to put this and make this h of t. I may have to change that to x. I'll see in a second. No, I guess not. And then I'll put h of 5. So you can just type it into your calculator. I'm going to put h of 5, and it's 476 feet. High was the rocket 7 seconds after launch? 476 feet. What is the maximum height? And what is the, when was it? Well, I can find the when first. Remember, this is a times t squared plus bt times c. And the vertex, the t component, usually it's the x. If it's y equals something x squared, it's the x component. This will be the t component, is negative b, negative 175, divided by 2 times negative 16. And that will be, and I have to round it to thousandths. Well, I'm just going to look at the vertex of this thing to find out where the maximum height is, because that's the vertex. And the x component is going to be at 5.469 seconds. So that's approximately 5.469 seconds. And then I would plug 5.4, I'd have to do the whole thing, 5.46875 in for t. In other words, find the y component, or in this case, the h of t component, and it's 479.516. 479.516 feet. This is seconds. And it says round to the nearest thousandth. And again, I would just plug in 5.469 for t in this equation. 16 times 5.469 squared plus 175 times 5.469 plus 1. I'd probably want to use every decimal point I had, and then whatever. When does it hit the ground? It hits the ground when the height is 0. So it's going to be negative 16 t squared plus 175t plus 1 equals 0. And you can use a quadratic formula. I'm going to use Desmos and just look at where it hits the x-axis, which is the ground. But the quadratic formula would be, this is a t squared plus bt plus c. I would do negative 175 plus or minus the square root of 175 squared. And now I have to scroll over so I have enough room. Minus 4 times negative 16 times 1, all divided by 2a, which is 2 times negative 16, which is negative 32. And if you plug that in, remember, it's negative b plus or minus the square root of b squared minus 4ac. And a is the number in front of the squared component, b is the number in front of just the letter, in this case t, and c is the constant. So in this case, that should be 175. It looks like a 115. I would plug that in, and I would find that I'm just going to look at where it crosses the x-axis here, and I'll plug it in just to show that it's right. It's going to be at, let's see, negative 0.00 6 seconds. Well, you can't be at negative 6 seconds. That's before launch. Or 10.943. Approximately 10.943 seconds. And let me just do this. I'll just put the quadratic formula in negative 175. I'll do plus square root of 175 squared minus 4 times negative 16 times 1. Whoops, I want that outside the square root. All divided by negative 2 times 16 is negative 32. Okay, so that's the negative one. I don't want the negative one. I want the positive one. 10.943 seconds. You can see it came out. And when was it 300 feet high? Well, then I'll do negative 16 t squared plus 175 t plus 1 equals 300 feet. I'll subtract 300 from both sides. Negative 16 t squared plus 175 minus 299 equals 0. And again, the quadratic formula for this one is going to be negative 175 plus or minus the square root of 175b squared, 175 squared, minus 4 times a, negative 16, times t, negative 299, all divided by 2a, negative 32. And I'm going to do mine on Desmos. I'll put equals 300, and I should get a number. Let's see if I get a beautiful number somewhere. Where is it? What's going on here? Well, I didn't get a number, so let's see what the problem is. I think that may be because I have a t there. Let's see. Well, I'll just put y equals 300 and see where they cross. That'll do it. It crosses at 8.818 seconds and 2.119 seconds. And I will show that this will come out right. Negative 175 plus the square root, because this is what you would be doing on the calculator, 175 squared. I don't think that they would ever expect you to calculate this by hand. Negative 4 times it. Oh, that's negative 299, not 1 anymore. All divided by our beautiful negative 32, 2.119 seconds, and then if I do the minus, it is 8.818 seconds. So it was again 8.818, approximately 8.818 seconds, and approximately 2.119. And then you can graph that. You're probably going to have to make a kind of a skewed graph where the x and y scales are different. This will be 5, this will be 10, and this will be 400. This will be 800. And then I can put in my various points. Remember, at h of 0, it's at 1. Well, that how do I draw that on a 400-point scale? Way down there. And I'll label it. That's 0, 1 is that point. And then at 5, it's at 476. That's 456, 500, 476 is somewhere around there. That's h of 5. The maximum height is 5.46 seconds. How am I going to do that? You know, that's so close to there. And then it falls back to the ground. When does it hit the ground? And I got 10.943 seconds. So 10, this will be 15, so it's somewhere around there. So it looks like that. You know, hits the ground there. It's very hard to draw because this thing, really, if you look at it on Desmos, by the time I zoom out and I can see how high it is, it looks like just a straight line. It's just a very thin parabola, but that's what it looks like, and I have answered all the questions.